Hi everyone, and welcome back to the Learn to Code by Writing Space Invaders course. We're now on lesson number 12, and in the previous lesson we had a look at one of the different looping structures, the repeat until loop. So that means we've covered now the for loop and the repeat until, and we're going to look at another one today, which is the while do loop. All of these then allowing us to exit from the loop under certain conditions. So make sure you load up your lesson 11 code, and we'll jump straight into tick 80 and make a start on this loop. The next looping structure is the while repeating structure. So that takes the form of while and then our tests for the exit do, and then we simply replace the bit down here. The loop ends. So let's just do space in and end. So what this says is, while this expression is true, do this loop. Okay, so let me just come down here. So again, it's the same idea as the repeat until loop, where we are explicitly specifying our looping conditions. If you think about it, we've got the condition we're looking at here is the continue to loop condition, whereas in the repeat until, it was until an exit condition. So can you say that it's actually the reverse logic to the until loop? So that makes sense. So we will continue doing the loop until our expressions become true, whereas in the until loop, we would stop doing our loop when the conditions came true. So that was an until the conditions become true. Again, we still have to do all of the counting, all the incrementing by ourselves. So that's all handled here. But what we do again is we can then simply write our expression here. So let's just simply do the expression that will exit at our normal time. So we're saying here, so while our count, and at this time it wants to be less than or equal to 10, we want to do the loop. Okay, so when we first come in here, our count value will equal 1. So count is less than or equal to 10, so that gives us a true for this expression. So while that's true, we do the loop. So we do the loop, we print out the first element, and we move the counter on to 2. We then come back up into our while loop. So 2 is less than or equal to 10, so we continue with our loop, 3, 4, and so on. Eventually we get to our count being updated and it becomes equal to 10. And at that point we come round our loop. Count is less than or equal to 10, so it's equal to 10, so that stays true. So we print out our 10th element. We then move on to our 11th element. We come back up round here. While count is less than or equal to 10, so it now is not less than or equal to 10. So our while condition has failed, and at that point we will jump straight down to the end of the loop and continue with the rest of our program. So if we run this one, we should find that we've got our same answer again with all 10 of our results being printed out. And then back into our code again. So we have it doing our natural end to our loop. But what if again we wanted to test for, let's say we wanted to also exit the loop when our squares value gets more than 50. So we want to be able to print out these first 7 results and then our loop exit. We have to be careful now, because in our repeat until loop we were chaining together various exiting conditions using an OR. So we were repeating until one exit conditions met, or another exit conditions met, or another exit conditions met. what we're now doing is we've now got, instead of exit conditions, we've now got continue conditions. So our logic has slightly changed here. So if we did an OR, so say OR, so squares count. So again, this is the condition to carry on looping round. So the condition to carry on looping round would be if our squares value is less than 50. Okay, so we said, so while our count is less than or equal to 10, or our squares value is less than 50. So let's see what happens if we run that. And we get an error coming in here. So again, it's attempted to compare nil with a number at line number 12. So let's walk through a code and see why it's doing that. So again, it's the same error we got before when we had our count trying to access a part of our array that didn't exist. So again, let's try going through to the sort of final versions of it. So let's say that we're coming in here and count is equal to 10. So our test here for count less than or equal to 10, that's going to be true. So our loop continues. So we print out element 10, which is 100. We then increment count to be 11, and we come back up round to our loop test again. So this time our count is not less than or equal to 10 because we've got 11 now. So this bit of our test is actually going to fail. But what we're doing here is we are using an OR. So what the computer says, if that bit's failed, I still need to test the second block, because if either of them are true, then the whole expression is true. So it actually tries to execute this bit of code, and of course squares index 11 is not, it doesn't exist, so that's where it's failing. And that's where we're getting this error then. So where it compares nil with number, so squares element 11 will return nil, and that is not allowed. So we need a different type of logic in this while loop. So really what we're saying is we want to loop while this bit has to be true and this block has to be true. So we actually want to do what's known as an AND comparison in here. So our loop only happens if both of these conditions are met. And that's what the AND says, if both of them have to be true. So again, looking at our 10, our count equal to 10. So we come in, we print out 10, we increment to 11, we then come round to here, and we say count must be less than or equal to a 10, and that one will fail. But because we're using an AND one, the computer knows that that has to pass, otherwise we don't loop anymore. So it doesn't need to calculate the second one, and therefore the loop condition will fail and we won't loop, so we will go to the end. So at this point now, we should now find that our loop works, and our two conditions will be valid for ending the loop. Either we get to the end of the array, or we find that the squares have gone greater than 50. So let's try that. And there we go, and we can see we've still got 10 elements in our array, but that the loop finishes once we get to 7 squared, because 8 squared is now more than 50. Okay, so that's our loops taken care of. So we've seen we've done a for loop, which is a very simple one where it will do the counting for you and it will automatically end at the end of the count. We've now done our repeat until loop, where we are testing at the end of our loop, and the test we have to do is we're testing to see if we have finished the loop. we now have our while do loop, where we have our test at the start of the loop, and we are testing to see if our loop needs to continue. Okay, so there's a slight difference. So on our until loop tests if we have to end. Our while loop tests if we have to continue. And we said on the repeat until loop, it will always execute at least once because our test is at the end of the loop. Here, if we were to set count equal to 11, our loop would actually fail at the very first try. We can actually try that. And you can see it prints out the number of elements in the array, but nothing other than that. So again, our loop fails at the very start, so we can actually have this loop executing 0 times. In other words, we can totally bypass the loop if our looping conditions aren't met at the very, very start. So we have our 3 types of loop. So let's have a look at our real code and see if we can work out which one of these loops will be best for our real software. So I'm going to come back out to our console. I'm going to save this little test program as loop, so I've got it saved in my system. I'm then going to load back in my lesson 10 code, which is where we had got to with our Space Invaders development, and come in here. Okay, so this is going to be lesson number 11. So let me just go out and save that so I don't overwrite my lesson 10 code. So we're going to save lesson 11, and that's all saved now. And let's go down and find our check player fire function. So there's our check player fire function. And let me go into a smaller font size so we can see what's going on. So really the decision on which type of loop to use really depends on how you're monitoring the condition to carry on looping and what affects the way in which you exit from that loop. Okay, so we know that we're coming down here and we have our loop taking place here. So at the moment we are doing a for loop, which is looping through and checking if we're fired and so on. So we are doing a test in here which tells us, in effect, that is a bit of code which allows us to bypass the actual loop code. So we still go looping round, but that little bit of code there lets us bypass this whole block of doing things code. Okay? So we need to work out a way in which we can use one of the other looping structures to actually stop it looping round and round doing nothing, but to actually just exit out of there. Really, we can use either of our loops, but both will work in this situation. But we need to work out how we're going to make them work. So we want to do our loop while we are looking for a bullet being fired. At least that's one way of thinking about it. We could also say we want to do our loop until we find a bullet has been fired. So can you see that either will apply here? So let's do one, and then you can have a go at doing it with the other version. Okay? So let's say that we want to loop until we find a bullet has been fired. So the position of our loop's going to be the same. So it's going to start here. So we can take that one out and we can put in our repeat code there. And let me just give it a couple of lines so we know where it is. And then the end of our for loop was there. So this will be our until block in here. So we're going to do until down there. So this is our loop then. So we know that we need to index our array using this bullet value, but we now know that that's not going to be automatically incremented for us. So we need to create a variable. So we're going to create a local variable called bullet, and we're going to set it equal to 1, because that's going to be the first element in our array. When you're declaring variables, you can do it right down here if you want. So we could actually put that right there. We could say local bullet equals 1 down there. But in quite a few languages, the convention is to declare your local variables at the start of your function, so that you know where they are declared, and also you can see if they have been declared or not. It's just another one of these helper things to make sure that you don't miss them. If you have your declarations spread all the way throughout your code, then sometimes it's hard to actually find if it has been declared or not, and sometimes you get clashes between variable names, and so just it is good practice, if that's the right way of saying it, to define your variables at the start of your function. So we've declared our array index counter here. So we're going to say repeat. So our if bullet fired equals false, we know that test, we're going to be doing that as part of our loop. So we can actually take that line out. And of course that has a matching end. So that's the matching end of that one down here. Okay. So we're going to repeat, and this is the code then that checks to see if we have found a bullet. So if this particular bullet we're looking at is not active, then we can fire it, and we signal that we have fired it by saying bullet fired equals true. So that code can work just as it stands. But what we now need to do is we now need to work out how do we exit from our loop. Because remember, the until loop has some conditions that allow us to exit. So we said the first thing to consider then is the natural end of our loop. So we know that if bullet is greater than our max player bullets number, then that is a condition to leave the loop. This bullet value then is the one that gets incremented each time we go through the loop. And again, we have to do that incrementing by ourselves. So inside our loop, just before we get to the test at the end, we have to increment our loop counter. So that loop, let me just clean up a couple of spaces here so we can see it all in one go. So we have our repeat until loop. So we're going to repeat. We're going to check if we can fire this bullet. If we can, we're going to fire it, and we're going to tell the system that the bullet has been fired. We're then going to move on to the next bullet, but we're then going to check if we've already looked at all the bullets, then we can exit. And of course we then want to or the other condition for us exiting is if bullet fired is true. And we can either say equals true, or we can just say if bullet fired, because that in itself will come back as true or false. So that should be our code now written to check for all the bullet firing. Okay, so let's see if that works for us. So if we come out and we run, we can go here and we should be able to fire off up to 5 bullets. And everything is working as it should. Okay, but our code is now using this repeat until loop, and as soon as we fire the bullet, we are exiting from the loop, because this condition here will become true, and saying it's true, we need to leave the loop. If we've got all 5 bullets already being fired, then of course we'll loop through all 5 goes and not find a bullet. And at that point, this condition, because we've checked all the bullets now, then this condition will become true, and that says you can leave the loop at this point. Okay? So that's the repeat until version. What I'd like you to do now is to have a go at the while version. Okay? So remember, the while version, we have the while plus conditions to continue looping up here. And then down the end, this just becomes an end statement. Okay? So I'll give you a counter on that one. So pause the video and let's see if you can figure that one out. Okay, so let's have a go with this one. So we've got a lot of the code already in place. So we already have created our indexing count, which is the bullet variable. And we've got it incrementing here. And we know that this code works correctly to detect if a bullet can be fired and then fires that bullet. So we just simply need to work out how our while loop fits around this. Okay, so our while loop is again going to be in the same place. So it's going to finish here with an end statement, and that's going to be the end of our while loop. And the while bit is going to go up at the top here, followed by some conditions. Okay, so remember, with the while loop, the conditions are what we need to have to continue looping. Okay. So the first one then will be our natural end while we're counting up. So while bullet is less than or equal to max player bullets. Okay. So this will count. So we need to go from 1 to 5. So 1 is less than it, 2, 3, 4, 5 then is equal to it. The 6th bullet is the one where we need to exit. Okay, so the 6th bullet, this expression becomes false, and that says do not continue looping. But we then need to have another condition, so there are 2 conditions that need to be met to keep this loop working. So we use our and the next condition then, which needs to go inside these brackets, has to do with our bullet fired variable. Okay, so remember, bullet fired equal to false means that we need to keep working through our loop. Bullet fired equals to true means that we have finished the loop. Okay, so this condition is a condition that we continue executing the loop. So at that point there, we have to have bullet fired having the value of false. Okay. And again, something being equal to having the value of false, we can write it in a separate way just to get used to these different notations. We could actually say not bullet fired. So that says if it's equal to false, if it has the value of false. Okay. So we do our while loop. We loop if both of these conditions are true. So we have to be less than or equal to max player bullets, and we have to still be looking for a bullet. Okay. So again, hopefully you can see there's a slight reversal of logic between the while loop and the repeat loop. So let's just see if that actually works then. And it doesn't, because of course our while loop is while expression and then do. So you need to have that word do at the end of your line. Okay, so let's have a look at that. And we go left and right and we fire off our bullets. Okay. So we now have, again, our nicely optimized bit of code, so it will check all the bullets if it needs to, but as soon as it fires a bullet, the loop will exit and we don't waste time going round and round. So whether you use the repeat until or the while do loop, it's really personal choice. There are certain situations where one does make a slightly better choice than the other, but as you can see, we can set the system up to allow either one to work. So let's so you choose whichever one you want to keep in your software. So I'm just going to leave the while loop in here to save me typing anything else in. I'm going to come out and I'm going to save that as my lesson 11, which I think I've already done, and then come back in. There's one last thing I want to show you. So don't worry about typing this in, but it is a method of making the for loop do this process of exiting as well. So I'm just going to nip back and get my lesson 10 code. So I'm going to load lesson 10. I know that lesson 10, if I go back into small font, we know that if I go to check player fire, that is using the for loop. So we're back now to the old for loop where it's going round and it will always go round this loop five times or max player bullets times, even if it has found a loop. So again, this idea of exiting from a for loop, it's obviously something which comes up a lot inside programming. I personally would choose one of the repeat until or while do loops, because they allow you to specifically see when you've hit one of the exit conditions. But there is a sort of a quick and easy way of fixing this loop, and that is using a special command called break. So our for loop executes here, and this is where we loop round, so from there to there. We have this bullet fired equals false idea, which was allowing us to mask off this block of code. But what we can do in here instead is we don't actually need that in this particular instance. So we can take off that if statement, because what we're going to do is we're going to come in, we're going to check if this particular bullet can be fired. If it can be fired, we're going to fire it. But then what we're going to do is, instead of bothering with sending signals to anybody, we are just simply going to tell the system to get out of our loop. And we do that using the break command. What this says then is start the loop off, check the first bullet, that might be already fired, check the second bullet, and we might find that we get to the third bullet, and that's the one that can be fired. So we do the firing, so that's the one that fires it. And what we then do is we have this break statement. And what the break statement says is just get out of the for loop. Don't do anything else, just jump out of the for loop. So at that point, it will say, I've just fired a button, and at that point, it will simply jump down to the end of the for loop and start carrying on. So we have exited the for loop. But it is a little bit of a nasty way of doing it, because it is not a nice programmed way, if you see what I mean. It's not a certain condition has been met. We're just simply saying let's just get out of the loop. In this situation, there's no problem doing that, okay? Because it's not going to create any confusion within the system. Where the confusion can come in is if you maybe have a loop where there are lots of conditions as to why you might break out of the loop. Sometimes having breaks spread around in lots of different places, it can sometimes be hard to find exactly where the loop is exiting. Whereas if you have a repeat until or a while do loop, and you have the conditions listed out, or you might be calculating conditions within your loop. When you come to that, you can see an exact list of what needs to be happening to keep the loop going. And if those aren't then met, you can start to trace back where they are. Whereas with the break statement, you sometimes have to sort of search through and work out why it's breaking out at certain points. And as well, when you start nesting loops inside loops, it becomes a bit awkward to work out whether the break's going to break you out of which layer of loops it's going to break you out of. So to say, for simple looping structures like this, the break is absolutely fine. And if you think, if you're happy using that, and there's going to be no confusion, then there's absolutely no reason not to use it. But if you're getting more complex looping structures and loops within loops within loops, then sometimes it can be better to use the repeat until and so on. Okay. But say, the idea here is to give you all the information you need. And again, programming is a very personal thing. Different people have different styles of programming, and it's whatever really works for you and you're happy with. And there's no real right or wrong answer. There's just working programs and not working programs. So that finishes off the bullet firing system. But I guess now we need to make a start on getting some aliens on the screen. So we'll make a start on that in lesson number 13. See you soon. Bye. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.